Right, year 13s. From exercise chapter 15, the numerical methods for integration, there is two parts to it, using the rectangles, then the trapezium rule. And this is one of the red questions from the bit on the rectangle questions. It's the one which says that this is the graph of y equals root sine x. And part A of the question says state the maximum value. Okay, state implies no working involved. Sine x would have a maximum value at pi by 2. We should know the shape of sine x. So the square root of all those values will still have a maximum value at pi by 2. So we've got pi by 2 is the x coordinate of that point. If we put pi by 2 into this, sine of pi by 2 is 1, the square root of 1 is 1. Okay, so, right, it's the second part of the question, which is the good bit. Second part of the question wants us to use 4 rectangles on the part of the graph shown to get a lower bound for the estimate of this. Okay, things to point out. It wants us to estimate between 0 and pi. We've got the graph up to pi by 2. So the first thing we should be appreciating is that the graph is symmetrical. Okay, so we're going to find the area under root sine x for 0 to pi by 2 and double it. Now we know it says, because this is an increasing function, if we fit the rectangles to this, let's do some random rectangles, let's do it like that. If I drew a rectangle between here and here and used the upper value, the right hand value to get the rectangles, is going to be above the line. That would give an upper bound for the area. If I chose to use the left hand values each time, I would get a lower bound. So in this case, for a lower bound for the areas, lower bound implies use y values at left hand end of rectangles. One last sneaky thing here. Between 0 and pi by 2, if I'm using the left hand end of rectangles, notice this first rectangle doesn't have a height. Arguably, if I did 1, 2, 3, 4 strips, the first one's not a rectangle. So if we split it into 5 equal width strips, so pi by 2 divided by 5, pi by 10. If I split it into strips pi by 10 wide, I use the left hand value each time, I have that rectangle with no height, which is not a rectangle, that one, that one, that one, and that one. 4 rectangles to estimate that area, which I'm going to double to get that area. So starting point is a table of values, which you could quickly generate on your calculator. So So we've got 0, pi by 10, add pi by 10 to that, you get pi by 5. You can check that on your calculator. And add another pi by 10, add another pi by 10, add another pi by 10. Checking you're in radians mode, work out the square root of sine of, let's put a fraction in, pi by 10. Sine of 0 is 0, I don't need to put that one in. So pi over 10, close bracket, and I get a first answer of 0.556. Easiest way to get the rest of them, if I'm not going to bother using a table function, use the cursor key and just change all the denominators. Pi by 5, 0.767, 0.899, 0.975, sine of pi by 2 is 1, and that one is 0. So the area of these 4 rectangles, 5 if you count that one with a area of 0, but 4 actual rectangles, is they all have a width of, so area of 4 rectangles is, they all have a width of pi by 10, so that can go outside a pair of brackets, and it's pi by 10 multiplied by that, pi by 10 multiplied by that, and by that. Oh, annoyingly put the bracket in the wrong place. And by that. I don't need to use the 1 because the 1 is the height. It's the height we're not using. It's the right hand end of the last rectangle, okay? In this case, 1, 2, 3, 4, 4 rectangles. So if I type that in, if I type in pi over 10 multiplying 0.556 plus 0.767 plus 0.899 plus 0.975, you get 1.004. Therefore, lower bound for the integral between 0 and pi of root sine x dx is twice that, which is 2.0123 sig fig. What should we try to emphasize at this point? Perhaps we should emphasize that when I multiply that and that, it's the area of that rectangle. When we multiply that and that, it's that rectangle. When I multiply that and that, it's that one. Because they've all got the same width, we can put it together as that calculation. So I'll just write that again so it's clearer. The width of the rectangles and then the sum of their heights. And the heights are y values. Because this is an increasing function, the left-hand values for rectangles will give us a lower bound. The right-hand values, if you can still see them, would have given these ones, which would be an upper bound. Do a lower bound and an upper bound, then you've got the 2 values, which the actual area is between. Can we find an actual answer? Yes, we can now, because we can use this button. In fact, perhaps we should, the final thing we could do is, I'm in radians mode, I can type in root sine x, close the bracket, put the limits in. Oh, they are there, so I have to put the limits in. So I can put the limits in of pi and 0, and I'm hoping that that's something that this is a value, 2.01 is a value less than that. Well, while we're waiting for it to come up with an answer, now that's good, isn't it? Perhaps this is a question which the calculator can't do. I'm just going to pause the video and see if an answer comes up.